everyone, today we're going to be talking about trigonometry. Now, when you hear trigonometry, there's two things that I want to come to your mind. The first thing is that we are working with triangles. Trigonometry is a part of geometry, probably the last lesson you'll see in it, that deals with triangles. And the second piece of trigonometry is finding information. So, taking these two attributes together, we're using triangles and we're using the information that we have with the triangle given to us to find further information. So that'll make more sense as we go with examples, but for now, just keep these 2 points in mind: triangles and finding information. The next thing that you should be thinking of when it comes to trigonometry is a saying that we use to remember some calculations, and that's SOHCAHTOA. And that may just seem like it comes out of nowhere, and it kind of does come out of nowhere. But breaking this down, this S, this C, and this T are all identities. So we're going to have sine, and that stands for the S. We're going to have cosine, and that stands for the C. Then we're going to have tangent, and that stands for the T here. And now, what we're going to have is this symbol right here, which we call theta. Theta is a Greek letter that we're just using to describe an angle that we do not know. So you could say sine of x degrees realistically, but common practice is just to say theta. So we'll put thetas in here, and we're dealing with the relation of sine to an angle, the relation of cosine to an angle, and the relation of tangent to an angle. So now that we know that, we can look at the rest of SOHCAHTOA to fill in our identities. So we have sine of theta equals opposite over hypotenuse, or O over H. Cosine of theta equals adjacent over hypotenuse, or A over H. And tangent of theta equals opposite over adjacent, or O over A. Now there's some sayings that will help you remember this, and I'll link them in the description. However, I'm not just going to start saying them off the top of my head, but if you can remember SOHCAHTOA and you say that a million times over, you will probably be able to do that just fine. So going beyond just the saying and these identities, we're going to actually break down what the O and the A and the H actually mean when we're working with examples. So let's just draw an example triangle here. It's going to look something like this, and we're going to imagine all these lines are straight on this triangle. So let's say we're working with this angle here, and it's not given to us. Rather, we're just going to give it a name, which is theta. And we'll call that theta degrees because we typically measure angles in degrees, especially when we're working with trigonometry. Now, keep in mind we got three letters that we're working with here. We're working with O, A, and H. O stands for opposite. A stands for adjacent. And H stands for hypotenuse. So those are the three that you have to remember when it comes to trigonometry. Now O is very simple. Let's do some color coordinating here, just so we don't get too lost. Okay, that's a little better. So when looking at O, that's the opposite. And when we're talking about opposite, adjacent, or hypotenuse, it's in relation to the angle that we either do know or don't know. So in this case, we don't know the angle, but we can still look. Opposite is directly across from theta, this unknown angle. So we can call this side O. Now, I would say go to adjacent next, but what might be easier is hypotenuse. Hypotenuse on a triangle is the longest side and will also be directly across from the largest angle. So we can see that this angle here is probably the largest angle, meaning that here we have the hypotenuse, the longest side on the triangle. And if you're familiar with the Pythagorean theorem, you're familiar with hypotenuse from there as well, and that's just specifically with right triangles. When it comes to trigonometry, we're talking about any triangle. So now when you've deduced two of the sides, you can just give the remaining side the identity. But what adjacent means is the angle that's next to theta, but not the hypotenuse. That's why I figured it would probably just be easier to do the hypotenuse first, get opposite out of the way, and then we can just figure out what adjacent is from there. And that's typically the way I go about it when it comes to triangles. Here we have some examples of trigonometry, and we're going to look at how to solve them and just go by step in understanding where solutions come from in these examples. So let's look at this first triangle here. We're given that theta is this angle, and we're also given theta. We know that the opposite is the length of 3, and we want to find the hypotenuse. So to start with that information, what I would do is first mark your angle, just so it helps you understand where it's at, and then mark your opposite side, which is directly across from the angle here. And then we know that we want to find the hypotenuse, and we know that the hypotenuse is directly across from the largest angle, and we could say that's about here. So we have the theta, we have the opposite side length, and we want to find the hypotenuse. If you've never done trigonometry, this seems like we have no information, but I will walk you through it slowly so we can look at what we got here. So when we look at SOHCAHTOA, which is our abbreviation for the relationships, we're going to use these to identify which relationship we want to look at. So we have the opposite side length, and we want the hypotenuse, which falls in this section here. So we're going to be using sine, because that's what S stands for. So we know that sine of theta equals opposite over hypotenuse. And this is going to be the key to solving this problem. So with that in mind, let's fill in some of this information. So we know that theta is 30 degrees. That's given to us in the example. And we also know that opposite side length is 3, but we don't know the hypotenuse. That's the information that we want to find in this example. So what we can do is use algebra, and this might be your first experience with algebra, so I will briefly explain it. On algebra, you have to do one operation on one side, also to the other side of the equal sign. So we can multiply both these sides by the hypotenuse, and we'll have h times sine of 30 degrees. And then since you multiply 3 over h by h, that gets rid of the h on the bottom. So 3. And then since we're solving for h, what we want to do is set h equal to 3 divided by sine of 30 degrees. So now with this in mind, we can solve for the hypotenuse. So you might want a TI calculator. I do have one here that we can use. We're going to do 3 divided by, and I'll put it in parentheses just so nothing messes up here, but sine of 30. And you want to make sure you have your calculator set to degree mode and that it's not in radian, which that might be the default. So plugging that into our trusty calculator there, we're going to have the hypotenuse equals 6 units. So using the information that we were given, we found the hypotenuse length, which is 6 units. So let's go on to the second example here. Now let's look, we have an angle given to us, and that would be 60 degrees. We know that the adjacent side is 3 degrees. We can see that this side down here is the hypotenuse. So we'll say that the adjacent would be 3 right there. And we want to find the hypotenuse. So that's what we want. So looking back at our SOHCAHTOA acronym up here, we know that we have the adjacent and we want to find the hypotenuse. So that means we're going to be using cosine here. An identity for that is cosine of theta degrees is adjacent over hypotenuse. And now we're going to go through the steps just like the last problem. So let's write this out. We have cosine of theta, which is 60 degrees, as that was given to us in the problem, is adjacent, which is 3, that was given to us, over hypotenuse, which we do not know. So we can work this just like the last problem. It's very similar. We're going to have hypotenuse times cosine, 60 degrees over 3. because we multiply hypotenuse each side. That'll cancel out this fraction here. And then we want to make sure we set the variable equal to something. So we're going to have it h equals 3 divided by cosine, which we can just call COS, that's abbreviation for it, over 60 degrees. And now we're going to plug that into our calculator again. So we have 3 divided by, I'm going to use parentheses just to make sure there's no calculation errors, and we get 6. So hypotenuse equals 6 units. And now this may look very similar to the other triangle, and I did that intentionally. I just flipped it around, showing that these ratios can be very similar across examples. And if you have the same triangle, you can use it to find everything about it. So let's look at this third example that we have here. We know that theta is 60 degrees. That's given to us. The opposite side is 4. We know down here is hypotenuse. It's the longest side on the triangle. You can just eyeball that. So we want to find the adjacent, which would be this side length. So looking at SOHCAHTOA again, we have the opposite and we want the adjacent. So we know we're going to be using tangent. You can write tangent of theta degrees equals opposite over adjacent. So let's plug that in down here. We're going to have a tangent of theta, which was given to us, and that's 60 degrees. And we're going to say that equals 4 over adjacent because we do not know the adjacent side length. Using our algebra, which is similar to the last problems, I structured this intentionally. We can say tan for tangent, that's its abbreviation, equals 4. And then we can set adjacent equal to 4 over tangent of 60 degrees. So we're going to use our calculator to find that again. Let's see here. So we got 4 divided by tangent of 60. So that gives us an adjacent of 2.3, just about. So we'll say the adjacent about equals, which is this squiggly here, 2.3 units. So we have some more examples. A big part of trigonometry is just practice, practice, practice. The more problems you do, the more comfortable you will become with them, and the easier they will be over time. So looking at this triangle, we're given that theta equals 50 degrees, hypotenuse equals 7, and we'll call this hypotenuse, and we're looking for the opposite, which is over here. So we know that we have the hypotenuse and we want the opposite, so we're going to be using sine here. So we know that sine of theta degrees equals opposite over hypotenuse. Now let's substitute that in with the information that was given to us. So you can say sin, that's the abbreviation for sine, is 50 degrees as theta was given to us, and we don't know opposite, so we'll keep that there. But we do want to find, well, we do have the hypotenuse, so we're going to be looking for the opposite here. And now this is a little simpler. All you have to do is 7 times sine of 50 degrees equals opposite, as that cancels out quite nicely. So let's plug this in our calculator. Shouldn't be too bad. Sine of 50, and then let's multiply that by 7. So here we're given that the opposite side, let's see what that was there, is equal to about 5.36. And when we're dealing with trigonometry, you're going to have a lot of abouts because side lengths can just be infinitely long and small. So we'll say that's just about 5.36 units because we're not given any specific unit that we're working in here. Let's look at this next problem. We got theta equals 40 degrees. Now the hypotenuse is 11. And we want the adjacent side, which is right next to the angle. We don't have that. So let's look at what we're working with here. We have theta. That's typical. We want to find the adjacent, and we have the hypotenuse. So we know that according to SOHCAHTOA, we're going to be using cosine here. So we'll say cosine of 40 degrees equals, and then adjacent, which we don't have, over hypotenuse, which we do have. And then again, easier problem. So 11 times cosine of 40 degrees equals adjacent. And let's plug that into our trusty calculator here. So we're going to do cosine of 40 and then multiply that by 11. So we have that our adjacent is about equal to 8.43. And then we'll use units because it's not specified. And let's look at this final example over here. We're given that theta is equal to 20 degrees. We know the adjacent side is 9. And this looks like this would be the adjacent side here. And the opposite side is what we are looking for. So we don't have the opposite side. So the two letters we're using is O and A. So we know that we're going to work with the T of SOHCAHTOA because TOA. So we will say that tangent, and then we have a theta of 20 degrees is equal to opposite, which we don't have, over adjacent, which is 9. So we can do 9 times tangent of 20 degrees equals opposite. And plug that into our calculator once more. So let's see, we got tangent of 20 times 9. And that's going to give us about 3.28. So we'll say opposite is about equal to 3.28 units. So these are all the basic examples, and now we're going to get into looking at some of the inverse trig functions. Last type of examples when it comes to trigonometry are inverse functions, which at first glance might seem a little intimidating, but honestly they're a little easier than the basic functions. So you know that you're dealing with an inverse function problem when you have two side lengths but you don't have theta. So what you're trying to solve for is theta. You're trying to find this missing angle in question. So we're still going to use SOHCAHTOA to figure out what identity we're working with here. So in this first example, we have the opposite and hypotenuse. So using SOHCAHTOA, we know that we're dealing with sine of theta equals opposite over hypotenuse. The only difference than the other problems that we were working with is that we just don't have theta, but rather we have the side lengths. So we know that we have 8 over 11 for opposite over hypotenuse. And what we're going to do to find theta is we're going to take the inverse function of sine. Now what that looks like is something like this. You're going to have theta equals, and then your function, which in this case we have sine. So we're going to say sine. But we're going to have this little -1 up here, which just means an inverse function. And then you still keep the opposite over the hypotenuse for sine. And now when it comes to the calculator, this is actually very simple to calculate. All you're going to do is click this little second button and then click sine. So that's going to give you the inverse function there. And then after that, you're going to plug in your side lengths, opposite over hypotenuse, 8 over 11, and it's going to return to you theta. So we see that theta is about 46.66 degrees. So we can plug that in. That is about 46.66 degrees. So these are slightly easier, require less computation, but I'd say we still go through 2 more examples to get comfortable with the situation. So in the second one, we're working with adjacent and hypotenuse using SOHCAHTOA. We can say that this is a cosine of theta angle is adjacent over hypotenuse, right there. And we're going to end up writing that down here. So we're going to say COS, abbreviation for cosine, is equal to theta degrees, which, well, cosine of theta degrees is equal to adjacent over hypotenuse, which is 11 over 17. We're going to use this same trick back there. We're going to say that theta degrees is equal to cosine inverse function, and then 11 over 17. We keep the same pattern there. We're going to plug this into our calculator yet again. So let's see, we're going to second cosine, that gives us the inverse cosine. And then we're going to plug in the adjacent over the hypotenuse, 11 over 17. And that's going to give us our theta here. So we're looking at about 49.68 degrees. Let's put that in. 49.68 degrees. And we gotta use squiggly equal signs because it's about 49.68 degrees. It's not exactly, so you do need that rounding sign there. Let's look at our final example. We have an opposite and adjacent using SOHCAHTOA. We know it's going to be a tangent function. So tangent of theta degrees is equal to opposite over adjacent. Now we will plug that in down here. We say tan for abbreviation of theta degrees is equal to opposite over adjacent. In this case, that's 7 over 6. We'll use our little trick to say theta degrees is equal to tangent inverse function, or inverse tangent. And then we keep opposite over adjacent. And we're going to use this to figure out what our theta is, our missing angle. So you'll hit second on your calculator, tangent, and then 7 divided by 6. And we're going to have that the missing angle here, theta, is about equal to 49.4 degrees. So let's write that in, 49.4 degrees. And this should be a squiggly equal sign because it's about 49.4 degrees and it's not exactly. So when it comes down to trigonometry, you're working with triangles and you're working with missing information to find new information. That might be where you have both side lengths and you're trying to find a theta, where you have a theta and one side length and you're trying to find another side length. But nonetheless, practice is going to help you, so just repeat this video a couple times, take notes, try to remember SOHCAHTOA, and you'll be fine with trigonometry. If you guys have any questions, feel free to leave them in the comments. Otherwise, feel free to subscribe, like, and share with your friends and family. Take care.